In this episode, we move into a topic that sits underneath a huge amount of good risk work, even though new learners do not always notice it at first. When organizations make decisions about risk, controls, priorities, and reporting, those decisions are only as useful as the information supporting them. If the underlying data is weak, late, incomplete, confusing, or misleading, even smart leaders can make poor choices with confidence. That is why data collection, aggregation, analysis, and validation matter so much in certified in risk and information systems control, risk, thinking. For a beginner, the easiest way to understand this subject is to see it as the journey from scattered facts to trusted insight. Risk management does not improve just because the organization has more numbers, more reports, or more dashboards. It improves when the organization gathers the right information, brings it together in a meaningful way, studies it carefully, and checks that it can be trusted before important decisions are made. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Data collection is the starting point because the organization cannot evaluate what it never captures. In a risk context, data collection means gathering the information that helps people understand exposure, control performance, process weakness, operational change, and business impact. That information can come from many places, including access reviews, incident records, vulnerability results, change activity, audit observations, vendor performance, policy exceptions, recovery tests, user behavior, and system logs. The important lesson for beginners is that collection is not about gathering everything simply because it exists. Good collection begins with a question about what the organization needs to know and why that knowledge matters. If leaders are trying to understand whether a control is weakening, the data collected should relate to that control and the conditions around it. If the organization is trying to understand third-party risk, it needs data tied to service performance, compliance expectations, dependency, and exposure rather than unrelated technical detail that makes the overall picture noisier instead of clearer. One reason data collection can become messy is that organizations often pull information from separate teams that work in different ways and use different tools. A business unit may record issues one way, a security team may track events another way, and an operations group may hold important information in yet another system with different timing, labels, and definitions. Even when everyone is acting in good faith, the result may be a pile of information that does not line up neatly. For a new learner, this matters because it shows that data problems are often governance problems as much as they are technology problems. If no one has decided what data matters, who owns it, how often it should be updated, and how terms should be used consistently, the organization may still collect a large volume of information without gaining much understanding. Strong collection depends on purpose, discipline, and shared expectations. It is not just a technical feeding process into a central tool. It is the intentional gathering of evidence that has a clear connection to business risk and decision-making. The quality of collected data matters immediately because weak data can damage the whole process long before anyone reaches the analysis stage. A common saying in technology and analytics is that bad information going in leads to bad conclusions coming out, and that idea applies strongly to risk management. If incident records are incomplete, if review evidence is missing, if dates are inconsistent, or if teams use the same term to mean different things, the organization may believe it sees a pattern that is not really there or miss a pattern that deserves urgent attention. Beginners should understand that completeness, accuracy, timeliness, and consistency are not abstract data management ideals. They are practical requirements for sound judgment. A monthly report built from old or partial information may look polished and still mislead leaders about where attention is needed. Collection works best when the organization asks early whether the information being gathered is current enough, detailed enough, and reliable enough to support the decisions that will eventually depend on it. Aggregation is the next major step, and it simply means bringing related data together so the organization can see more than isolated fragments. One team may know about access issues, another may know about vendor performance, and another may know about system downtime. But risk often becomes clear only when those pieces are viewed together. Aggregation helps leaders move from scattered observations to a broader understanding of trends, concentration, dependency, and recurring weakness. For a beginner, a useful mental picture is to imagine separate puzzle pieces sitting on different desks across the company. Each piece contains some truth, but no single piece shows the full image. Aggregation places those pieces into a shared view so that leaders can see where signals connect, where patterns repeat, and where one problem may be influencing another. That makes aggregation far more than an administrative convenience. It is one of the main ways organizations escape siloed thinking and build a fuller understanding of how risk is developing across processes, systems, business units, and third-party relationships. Aggregation sounds simple, but in practice it is often one of the hardest parts of the process because information from different sources rarely arrives in the same shape. One system may use broad categories while another uses highly specific labels. One team may update records daily while another updates monthly. A vendor report may use definitions that do not match internal language, and duplicate records may make the same problem look bigger or smaller than it really is. That is why aggregation often requires normalization, which means making data more consistent so it can be compared and combined meaningfully. Beginners do not need to get lost in technical detail to understand the key point. If two sources count similar events in fundamentally different ways, putting them side by side can create confusion rather than clarity. Strong aggregation depends on agreeing what important terms mean, aligning time frames where possible, resolving duplicates, and documenting assumptions so that the combined view is not only larger than the individual pieces, but also more trustworthy and more usable. Once data has been collected and aggregated, analysis is what turns it into something decision-makers can actually use. Analysis means examining the information to identify trends, outliers, relationships, recurring issues, weak points, improving conditions, or signs that risk is moving in the wrong direction. This is where the organization starts asking more thoughtful questions. Are control failures increasing in a specific business area, or are they scattered evenly? Are vendor issues becoming more common after contract changes? Are policy exceptions staying temporary, or are they slowly becoming permanent features of the operating environment? For beginners, the easiest way to think about analysis is as the stage where raw information becomes judgment support. It is not enough to know that 20 incidents occurred, 10 reviews were late, or 3 vendors missed a performance target. Analysis asks what those facts mean together, whether they represent coincidence or pattern, whether the direction is improving or worsening, and what business decisions should follow from that understanding. Good analysis always depends on context, because numbers can look meaningful while saying very little if nobody understands the business situation around them. A certain volume of incidents, access changes, policy exceptions, or recovery issues may be normal in one environment and alarming in another. The same trend can signal improvement in one case and growing strain in another depending on what the organization is trying to do, how quickly it is changing, and what level of exposure is acceptable. That is why mature risk analysis does not stop at counting events. It asks how the data relates to critical services, sensitive information, legal obligations, organizational priorities, and known control conditions. A beginner should also understand that analysis involves comparing data to expectations. If access reviews are being completed, but only after long delays in the most sensitive systems, the story is different from a simple statement that reviews occurred. Analysis gives meaning to data by connecting it to business importance, risk appetite, control objectives, and the consequences the organization is trying to avoid. A common beginner mistake is assuming that more data automatically leads to better decisions. In reality, too much poorly chosen information can overwhelm attention, bury meaningful signals, and tempt leaders to focus on what is easiest to count rather than what matters most. Organizations sometimes produce beautiful reports filled with activity measures that look impressive but do not really explain risk. Another mistake is assuming that analysis is neutral just because numbers are involved. Human judgment still shapes which data is collected, how it is categorized, what comparisons are made, and what story gets told from the results. Bias can enter when teams look only for evidence that confirms their existing view or when they ignore inconvenient signals because those signals complicate a preferred narrative. For beginners, this is a valuable warning. Good analysis is disciplined, but it is not automatic. It requires curiosity, challenge, skepticism, and enough business understanding to distinguish between useful indicators and attractive noise that makes the organization feel informed without actually becoming wiser. Validation is the final step that gives the whole process credibility, because data and conclusions should not simply be accepted at face value. Validation means checking whether the data is accurate, complete enough, timely enough, and consistent enough for the intended purpose, and also whether the interpretation drawn from it makes sense. This may involve reconciling figures across systems, reviewing source records, testing samples, challenging assumptions, resolving gaps, or confirming that a reported trend reflects reality instead of a change in categorization or timing. For a beginner, validation is where the organization asks whether it can trust what it thinks it knows. That question matters because bad validation can lead to confident reporting based on misunderstood inputs. An apparent drop in incidents may look like success when it actually reflects delayed reporting. A sudden rise in exceptions may look like growing control weakness when it really reflects improved issue identification. Validation protects decision-makers from acting on illusions created by data errors, misalignment, or incomplete interpretation. Validation also applies to the business meaning of the analysis, not just to the source records underneath it. A risk team may conclude that a certain area is improving because control failures are declining, but that conclusion should be challenged if staffing fell sharply at the same time and monitoring became weaker. In that case, the lower failure count might reflect reduced visibility rather than real improvement. This is one of the most important ideas in the topic because it shows that validation is not merely a technical quality check. It is also a reasoning check. The organization needs to ask whether the conclusion fits the broader environment, whether alternate explanations exist, and whether the data is being understood in a way that matches operational reality. Beginners often think the hard part is generating the report, but the more important task is making sure the report means what people think it means. Validation keeps leaders from mistaking cleaner numbers for a healthier environment when the underlying conditions may still be weak or even worsening. Strong governance supports every stage of this process because data collection, aggregation, analysis, and validation do not work well when ownership is vague. Someone must define what information matters, who provides it, how often it is updated, how key terms are used, how conflicts are resolved, and who reviews whether the resulting picture is dependable. Without that structure, teams may protect their own definitions, delay updates, or produce reports that cannot be compared because each part of the organization is speaking a slightly different language. For a beginner, this is another reminder that good risk information is not created by software alone. It is created by people and processes that agree on purpose, discipline, and accountability. Governance also matters because trust in risk reporting takes time to build and very little time to damage. If leaders discover that the same data point means different things in different reports, or that figures change without explanation from month to month, confidence in the whole information process begins to weaken. A practical example helps make the full cycle easier to picture. Imagine an organization wants to understand whether its patching process for critical systems is reducing risk effectively. Data collection would involve gathering information about missing patches, system criticality, overdue remediation, change windows, approved exceptions, and maybe incidents connected to known weaknesses. Aggregation would bring those inputs together from technology teams, vulnerability scanning, operations records, and exception tracking so they could be viewed in one place instead of remaining scattered across separate tools. Analysis would then look for patterns, such as whether overdue items are concentrated in certain business units, whether exceptions are becoming more common, or whether delays are tied to fragile systems that cannot be updated easily. Validation would check whether the source data is current, whether systems are categorized correctly, whether duplicate records are inflating the problem, and whether the conclusion truly reflects patching performance rather than hidden reporting gaps. That example shows why the 4 stages belong together. If any stage is weak, The organization may reach the wrong conclusion about whether exposure is improving or quietly expanding. Another important lesson is that this process is continuous rather than one-time. Organizations change constantly, which means the data that mattered 6 months ago may no longer be enough today, and the way information is combined or interpreted may need to evolve as business priorities and risks change. New systems are introduced, vendor relationships deepen, regulations shift, and attackers adapt, so the information process must adapt too. For beginners, that means data collection, aggregation, analysis, and validation should be viewed as a living cycle rather than a reporting ritual. The goal is not simply to produce a report for a meeting and then forget how it was built. The goal is to keep learning from the environment, refining the inputs, improving the comparisons, and testing whether the resulting picture still reflects reality well enough to support decisions. When this cycle matures, it helps the organization become more self-aware. It notices change earlier, explains risk more clearly, and responds with better judgment because the information foundation is stronger. As we close, the most important idea to carry forward is that risk management depends heavily on the quality of the information flowing through it. Data collection gives the organization raw material, aggregation brings related pieces together, analysis turns those pieces into useful insight, and validation checks whether the insight deserves trust. C-Risk expects you to understand that none of those stages can be neglected without weakening the overall result. If the organization collects the wrong information, combines it badly, interprets it carelessly, or fails to challenge its conclusions, its risk decisions may sound confident while resting on a weak foundation. For a new learner, this topic becomes much easier once you stop seeing data as a technical side issue and start seeing it as the evidence layer of risk management itself. Good decisions depend on good information, and good information depends on a disciplined process that moves carefully from collection to aggregation to analysis to validation. When that process is strong, the organization can act with far more clarity and far less guesswork.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.